Assalamualaikum and hi everyone. Before we begin, I'd like to introduce the members of our group. They are me, Muhammad Hisham bin Azmi, then Hirzi Bariki and Muhammad Hafizi bin Mustafa. Now, let's begin our presentation on the electron microscope. Hi everyone, in this video, we're going to talk about a very powerful scientific tool called the electron microscope. Unlike a normal microscope that uses light, the electron microscope uses a beam of electrons to look at objects that are extremely small, even smaller than what a light microscope can see. It was first developed in the 1930s, and since then, it has played an important role in fields like biology, medicine, and nanotechnology. Let's take a closer look at how it works, what it's used for, and why it's such an important invention. An electron microscope works by shining a beam of electrons onto a sample instead of using light. Electrons have a much smaller wavelength than light, which means they can show us much finer details. There are two common types of electron microscope. The first is the transmission electron microscope, or TEM. It lets electrons pass through the sample and give us very little to the image. The second is the scanning electron microscope, or SEM. It scans the surface of the sample and creates a detailed 3D image. To make all of this work, the microscope needs a vacuum environment and the samples often need to be specially prepared.
So I'll be talking about the detailed exploration about the scanning electron microscope and the transmission electron microscope. Here we'll be seeing the material failure analysis with electron microscope. When a critical component fails, like a turbine blade, a bridge joint, or a circuit, it is essential to know why. Electron microscope plays a key role by relieving the microscopic and even atomic level causes such failures. So now I'll be talking about the scanning electron microscope, the fracture surface analysis. I'll be talking about the functions and the limitations. So the function is that it scans the surface of a sample using a focused beam of electrons. It produces a 3D-like high-resolution surface images, and it detects secondary electrons, backscattered electrons, and X-ray. And the limitation is that it can't see internal structures, only the surface. The second one is that it requires a vacuum environment, can't use with wet or living samples. And last but not least is the non-conductive material must be coated with gold or carbon. So the next one is that I'll be talking about the transmission electron microscope deep defect analysis. So I'll be talking about the functions and limitations again. So the function of the transmission electron microscope is that electrons transmit through an ultra-thin sample. The second one is that it gives 2D images of internal structures at atomic resolution, and it is capable of visualizing or like cell organelles, crystal lattice, and defects at atomic scale. And the limitations of the transmission electron microscope is that the sample must be ultra thin. And the second one is that it is a complex prep, beam sensitive materials may be damaged, and last but not least is that it can cause false features. So I'll be talking about the real world applications and implementations. We have three career paths, which is nanotechnology, the second one is biology and medicine, and the third one is the electronic and forensics. So the application for nanotechnology is that it analyzes metals, polymers, and composites. They study materials about atomic level and molecular level, and it also detects structural flaws and lattice defects. The users of this nanotechnology is engineer labs and nanotech companies and R&D centers. So moving on, the application about biology and medicine is that it visualizes viruses and cellular structures. It is on a microscopic level, and it also study cancer cells and organelles like mitochondria. The users of this are the research institutions and pharmaceutical companies. In the university, they also have this. And last but not least is the electronic and forensics. The application of it is that it inspects microchips and circuits for manufacturing defects. Second one is that it analyzes forensics evidence like the gunshots, residue, or fibers. For these users is that both law enforcement and crime labs and the semiconductor manufacturers.
Okay, now we are going to talk about the next slide, which is potential benefits and future developments of electron microscope. So for the potential benefits, we have for here, the first one we have ultra high resolution imaging, which is it allows scientists to observe structures at the atomic level. The second one is advance in biology and medicine, which is it helps in virus research, cancer studies, and drug development. The third one is about material science and nanotechnology, which is its potential because it enable analyze of crystal structures, defects, and nanoparticles. The last one we have industrial applications, which is it improve quality control in semiconductors, metallurgy, and manufacturing. So now let's take a look at some exciting future developments in electron microscope technology. So the first one, we have the integration with AI. Future electron microscope will likely include artificial intelligence that can automatically analyze image, detect defects, and even interpret data, making the analysis faster and more accurate. The next one is higher precision with less damage, which is scientists are developing low dose imaging techniques to reduce the amount of radiation use, which is especially important when examining sensitive biological sample. The third one for real time imaging, this could allow us to watch processes at the nanoscale as they happen, such as chemical reactions or structural changes, something not yet fully possible today. And the last one is about increased accessibility. So efforts are being made to reduce the size and cost of electron microscope, which could bring this powerful technology into more schools, hospitals, and research labs around the world.
To sum up, the electron microscope is a very powerful tool that lets us see things too small for a regular microscope. It has helped scientists make many important discoveries, especially in areas like cell biology, material science, and medicine. As technology continues to improve, electron microscope will become even faster, clearer, and more useful, helping to us understand the tiny world around us better than ever before.